Hello, this is the video explaining assignment 3. I will start with the part 2 and follow it up with part 1. So here in the first two cell, I import the text that needs to be analyzed from nltk.book. So today we are taking text 2, text 5 and text 6 for analysis. Now I will combine these three texts together and we can see the length of the text is 203,553. Now I will create the bigrams from NLTK and then create a conditional frequency distribution from them. And we can see that the frequency of B of 2 followed by B is 0.0957. Now I will create a vocabulary of unique words from the text, and I'll create a conditional probability distribution with Laplace smoothing. And we can see the first five words that appear with 2 are engage, a, supply, whom, bequeath, and the maximum frequency word is B and the probability is 0.027. Now here is the model that will generate the random sentences. It accepts a conditional frequency distribution, a word of whose the word with which the sentence will start, maximum number of words that needs to be generated, and selection strategy. Now the selection strategy has three valid values, 0, 1 and 2. 0 means we will always display the word with maximum frequency. 1 means we will randomly select a word from the list of words that appear with the given word and display it. And the third strategy says we'll randomly select a word with the given probability. So we pass it the Laplace smooth conditional frequency distribution, the word V, a maximum words of 40 and a strategy of 0. So we will display the max word, the word with maximum frequency. So this gives us this text. Now we apply the strategy 1 to the same and we get this, and now we apply the strategy 2 and we get this sentence. So this completes the part 2. So this is the part 1 of assignment 3. So after importing the required packages, I here divide the data set into two parts, with the first part is pre-World War I and the second part is post-World War I. So we see that there are 32 items in pre-World War and 23 in post. Now I create raw text from pre-World War, examine its length, raw text from post, examine its length. Then I create a function to filter out punctuation and stop words from unigrams and from bigrams. Then I create unigrams and downcase them by using the function inaugural.words. I have used this function instead of the raw text because it gives the result closer to what the professor had given. So I do this and examine the length of the unigrams. Then I do this for post World War I and examine the length of the unigrams. Then I create frequency distribution for pre-World War unigrams, and the length is 6,867. In this cell I display the frequency distribution with the word, its count and its probability. I do the same thing for post World War I unigrams, and then I display the word count and probability for them. Then I sort the list of unigrams by their frequency and take the first 200 of them in a list, and then to this list I append the first 200 most frequent unigrams from the post-World War text, and we see that the total length is 400. Now I reduce this list to a set of unique unique unigrams. So we get 261 unique unigrams. Now I remove the words with length less than 2, so we get 227. Then I remove the punctuation and stop words, we get 160 unigrams. Now I sort these unigrams in a lexicographical order, and this is what we are left with. Now I create the information in the format of Word, their pre-World War I probability and their post-World War I probability, and save it into a file unigrams.txt. Now I create bigrams from the pre-World War and the post-World War I unigrams, and I examine the length of both of these. Then from these I create the bigrams, and I take the first 1000 most frequent bigrams from pre-World War bigrams, and then up to them append the 1000 most frequent from post-World War, and we see the top 10 items for them. Now I again reduce it to a unique set of 1526 bigrams, remove the bigrams in which any of the word is less than length 2, then remove the punctuation and stop words, and I'm left with 36 bigrams. I sort it in a lexicographical order and output the pre-World War probability and post-World War probability in a file bigrams.txt. Now here I again create the bigrams from the raw text, remove the stop words, punctuation, and words less than 2, and then I output the probabilities of pre-World War and post-World War bigrams into a list. Then I sort this list in the order of where the bigrams have most difference in their probabilities, in their post and pre probabilities. Then I display the top 50 bigrams of that, create a data frame, and display them in a plot, which looks like this. Now this function is for the last part of the homework of the assignment 3, part 1, which is to calculate the pointwise mutual information. So this function is basically the same as provided by the professor. The only part that I have added is, before spitting out the frequency distribution for unigrams and tuples, it removes the words length less than 2 and punctuation and stop words. So this is the function. Then it runs for pre-World War I tokenize the pre-World War I raw text, length of the tokens. Then I filter out the punctuation. Then I call the function to create the unigrams and the conditional distribution, and then I display the frequency distribution for unigrams. So we can see that here. Then I display the conditional frequency distribution for bigrams, that we can see here. Then I work the same thing for post-World War, create tokens, filter out punctuations. Then I call the function to create the frequency distribution. So this is the post-World War frequency distribution. This is the conditional frequency distribution for bigrams. And then I have written this function to calculate the PMI. I send it the unigram frequency distribution and the bigram frequency distribution and the length of the tokens. So this is for in this function I calculate the PMI as the log of bigram frequency distribution of the key passed in multiplied by n divided by the unigram frequency distribution of each of the word, and I keep appending them. Then I sort the list PMI list in the reverse order from greatest PMI to the lowest PMI. I calculate this for the unigrams, for the pre-World War I unigrams, and then I display the 100 pre-World War I probabilities. Then I create the I extract the PMI for the word economy in the pre-World War I PMI list, and then I do the same for the post-World War I text. I calculate the PMI, then I examine them, then I extract the economy, and then I display it in the format that was required, and here I output it into a file called pmi.txt. So this sums up the assignment 3.